In this video, we will discuss one of the most important components of GDP. We know that GDP could be decomposed into consumption, investment, government spending, and net exports. Understanding the determinants of each one of these components can explain the total demand. So, looking at the consumption function, we'll see that consumption depends mainly on disposable income, which means the portion of your income that you can spend. This is usually calculated as your total income minus taxes. And the relationship here is positive, meaning that increasing disposable income would lead to increases in consumption. So both variables move in the same direction. And the relationship goes from income to consumption. So when your income increases, your consumption increases too. This is called a behavioral equation, which captures the behavior of consumers, how consumers respond or behave when their incomes increase. Assuming there is a linear relationship between income and consumption with two parameters, C0 and C1, we could rewrite the behavior equation into a linear form as C, the consumption, equal C0 plus C1 YD. Again, YD here is the disposable income. C0 here is the consumption level when your disposable income equals 0. Obviously, even if your disposable income equals 0, you still need to consume a certain level of consumption for survival. So consumption cannot start at 0 point even if your income equals 0. So that is 0, that is C0. The other parameter here is C1. C1 here represents the marginal propensity to consume. It's a very important concept which refers to how much you will spend or you will increase your consumption if your income increased by £1. Okay, so if the marginal propensity to consume equal 60%, 0.6, so that means for every pound increase in your disposable income, 60p from that pound will go on consumption. That is what marginal propensity to consume refers to. And this parameter should equal somewhere a value somewhere between 0 and 1. C0 or C0, the minimum level of consumption, I'd say, if your, or the level of consumption if your disposable income equals 0, this has to be a positive number. So C0 here has to be more than 0, so it has to be positive. C1 is positive, the sign is positive, just because we expect the disposable income and consumption to move in the same direction. So that's why we expect a positive sign for C1. In terms of the magnitude, how much that could be, it's going to be a value from 0 to 1 or from 0 to 100%. So in the example I gave a moment ago, when your income increased by £1, you spend on consumption 60p or 60% of the income increase going into consumption. That makes the marginal propensity to consume 0.6 or 60%. So your marginal propensity to consume or marginal propensity to consume in any economy will be a value between 0 and 1. We could present the same information in the consumption function in a graph. On this graph, we plot the disposable income on the horizontal axis and the consumption level on the vertical axis. And as we said, we already assumed that the relationship between disposable income and consumption level is linear, which means we could represent that by a straight line, and that straight line will be upward sloping line. Why? Because we know from the behavior equation that the relationship between disposable income and consumption is positive. So we also know that the marginal propensity to consume is somewhere between 0 and 1, and that is going to be the slope of our line. So the slope of this consumption function should be equal to C1, or the marginal propensity to consume. However, the position of that line will be determined by the level of C0, or the level of consumption when disposable income equals 0. As you can see on this graph, C0 here, or C0, decide or determine how high or low that consumption line or consumption function would be. So these are two important things we should learn from this graph. First, the level or the position of that line will be determined by the level of C0, the level of consumption when your income or disposable income equals 0, and the slope of this function is determined by the marginal propensity to consume, which again, it's positive. That's why we have upward sloping curve or line. And in terms of the magnitude of C1, or the marginal propensity to consume, we already know it's going to be between 0 and 1. Going back to our linear representation of this behavior function, we know that this is the consumption function. This is consumption, depends on C0 to some level that is not dependent on disposable income. So regardless of the level of your disposable income, this is the level of consumption you will need. And C1 is the marginal propensity to consume. YD is the disposable income. So what is YD exactly? As I said before, YD is Y minus T, is your income minus taxes. Of course, this is exactly what you have. So it's equivalent to Y minus T, and this is what you can spend. That is what is available for you. So replacing YD in this equation, in the first equation, in the consumption equation, would give us this equation here, where again C, the consumption level, depends on or equal C0 plus C1. C1 is the marginal propensity to consume, multiplied by this Y minus T. Again, this is just the disposable income. Let's now talk about demand for goods. How about the other components of total demand? As we said, total demand could be decomposed into consumption, investment, government spending, and net exports. Assuming we have a closed economy, so we'll assume that net exports equal 0, so a hypothetical economy that does not have relations with the outside world or other countries, just to simplify the analysis. But then adding this into the analysis should not complicate it further. It should be very straightforward to understand. But for now, let's just assume we have a closed economy where net exports equal 0. We will make some assumptions in terms of the other components. We will assume that those components are exogenous, are determined outside the model. We explained what the difference between exogenous and endogenous variables before. So at the moment, we will think of investment as an exogenous variable. That's why we denote investment as I bar. So that bar just refers to the assumption we make in here about investment being an exogenous variable. So assume that firms do not hold inventories. That would mean production equals demand. How about the other component, the government spending? T and G describe fiscal policy. These are the choices of taxes and spending by government. And for now, we will assume that G and T also are exogenous variables. Governments do not behave with the same regularity as consumers or firms. So for now, we just assume we'll take these as given. they are determined outside this model. Investment, again, we assumed it's exogenous as well. So for now, we're going just to assume that these two components, government spending and investments, are exogenous variables. In such case, when we have a closed economy, then Z here, or the total demand for goods, would be equivalent to consumption expenditure, investment, and government spending. We could use the consumption function, or what we learned so far about the consumption function, to replace C and I in this equation. So obviously we assumed I to be exogenous, so we mainly replace C with the linear form of our consumption function. So that would give us, here's the consumption function. We already know it's a linear function, or that's what we assumed. And this part now is the consumption. Adding to this investment, which we again assume to be exogenous, plus G, which again we assume to be exogenous as well. Now let's talk about the equilibrium, or drive the equilibrium condition in the goods market based on what we've seen. Again, the condition is total output or total production equal total demand, assuming there will be no inventories. So we replace Z, the total demand, with its equation. So now we know that Y, the output level, equal this part, which is the total demand Z. And from here, we can drive the equilibrium condition in the goods market. In equilibrium, production Y is equal to demand, which in turn depends on income, or Y, which is itself equal to production. We could write this equation by just expanding this bracket here in red color. So Y equals C naught plus C1Y minus C1T plus I plus G. Then we rearrange this equation. Just notice that we have Y on the left hand side and Y on the right hand side. So bringing these together in one side and dividing by 1 minus C1. So that, again, just rearranging this. And if you divide by 1 minus C1, this will give us the equilibrium condition in the goods market. So that's Y equal 1 over 1 minus C1. Remember, C1 here is the marginal propensity to consume. That's multiplied by C naught. This is some level of consumption that does not depend on the income level, or Y. I bar, we assume that to be exogenous. It's not determined in the model, so it does not depend on Y. The same thing, the same assumption we made about G, and minus C1 T. So this is the equilibrium output in algebra, using algebra. So that's the condition. Looking at this, we will see two components. Looking at this equation, you'll see two components. One, which is the autonomous spending. So the sort of spending that does not depend on the income level. So we know C naught does not depend on the income level. So this is the consumption level when your income or disposable income equal 0. So we know that also investment, we assume that's something determined exogenously. The same thing for G and T. So meaning that, again, this component here in the red color, that is the part of the autonomous spending, and that's part of the demand for goods that does not depend on income or output. In addition to this autonomous component, we can see 1 over 1 minus C1, that's in red color, and that is called the multiplier. So 1, again, remember, C1 here is the marginal propensity to consume. 1 over 1 minus C1, that is called the multiplier. Of course, the value of this multiplier will be larger when C1 is closer to 1. Remember, C1, the marginal propensity to consume, will take some value between 0 and 1. So the closer that value to 1, the larger the multiplier will be. So, for example, a marginal propensity to consume, or C1 equals 0.6, that will make the multiplier equals to 2.5. What does that mean? An increase in consumption by £1 billion, increase output by 2.5, the value of the multiplier, multiplied by this £1 billion. So that gives us 2.5 billion pounds. So the value of the multiplier here determine the effect of an increase in consumption or an increase in any of the other components in the autonomous spending. So in our example here, having a multiplier of 2.5, and there was an increase in consumption by £1 billion, that will result in, it's not one-to-one impact on output, it's actually 2.5 times that 1 billion increase. That will give us 2.5 billion increase in total. To present this equilibrium graphically, you could plot the production function or production as a function of income. Because production equals income, the relation could be represented by the 45-degree line, which starts from the origin point. Then you could plot demand as a function of income, just regrouping terms for autonomous spending. You will see in this equation that you have two components again. One component, which the autonomous spending, which again will determine the position of our function, our demand function, and the other component, C1y, which will determine the slope of that function. In equilibrium, production equals demand, and this is how it looks like. So we have the 45-degree line, which denote all the points where production equal income, and we understand this is our equilibrium in the goods market. And now adding to this graph the red line, which represent the total demand function, we'll see again the two components that I highlighted in the previous slide. One is the autonomous spending, which determine the position of that line, how high or low the demand function will be. That is determined by the autonomous component, autonomous spending component. And the other parameter is the slope, which is the marginal propensity to consume. So the slope of that function, ZZ, or the total demand function, is going to be determined by the C1 or by the marginal propensity to consume. So now let's think of how this equation, or where is the equilibrium here. So the equilibrium here happened at point A, where this intersection happened between the Y and Z. Y is production, output, presented by this 45 degrees line, and the total demand is presented by the red line. The intersection between both, denoted here as A, represent the equilibrium point where production equals demand, or Y equal Z. So now let's think of what could change this point A. One thing to change this position or this equilibrium is an increase in autonomous spending, any of the autonomous spending components. Let's say there was some increase in autonomous component, and that would shift our total demand function, which is represented by ZZ, and the equilibrium was point A. That will shift that function, so that the increase in autonomous spending will shift that function upward. Okay, remember, because there was an increase in autonomous spending, that will shift the ZZ line, or the total demand function, to ZZ prime. And now we will have a new equilibrium point, which is A prime. And remember, because of the effect of the multiplier, we're not going to have, or we expect to have, more than 1-to-1 increase in output. Okay, so depending on the value of C1, or the value, of 1 over 1 C1, or 1 over 1 minus C1, that is the multiplier. So depending on that value, which again is determined by the marginal propensity to consume anyway. So depending on that value, then the output will change. We know how much the output will change by. So we know it's not going to be 1-to-1. It's going to be, or it's not going to be 1-for-1. It's going to be more than that. So depending on the value of the multiplier, that will determine how far y prime will be from y. So having a multiplier, let's say, of 5, and let's say we assume like a 1 billion increase in one of the autonomous spending components, that would mean the y prime would be 5 times 1. So that's how far it will travel from y. How does that work? Once the autonomous spending increased, that will be a first round increase in production and in income, because what you spend, that would represent income to others. And when those people receive an increase in their income, they will do exactly the same thing like you. So they will, depending on the value of C1 or the marginal propensity to consume, they will spend a portion of that income increase. And when they do so, then that will represent another round of spending and another round of income for other groups. Again, those who receive those incomes, they will do exactly the same. They will spend part of their income, again, depending on the value of the marginal propensity to consume, and so on. So one off increase of autonomous spending will create several rounds of increases in production and income, and that's why y prime here would travel farther away, more than 1-for-1 change or increase in output in response to an increase in autonomous spending. So the total increase in production after n+1 rounds could be obtained basically using the multiplier, which again, as we said before, it's 1 divided by 1 minus C1, or 1 minus divided by 1 minus the marginal propensity to consume. Just to summarize what we said so far, production depends on demand, which depends on income, which is itself equal to production. So an increase in demand will lead to an increase in production and income, which in turn means future increase in demand. The increase in output will be larger than the initial shift in demand by a factor equal to the multiplier. The multiplier depends on the propensity to consume, the marginal propensity to consume. The multiplier can be estimated using econometrics, a set of statistical methods used in economics. So this is something we're not going to cover in this course. The adjustment of output over time, called the dynamics of adjustment. How long the adjustment takes depends on how and when firms revise their production schedule. Now let's move on to talk about a very important relationship in the goods market, which relate investment to savings. So far, we know that equilibrium requires the equality of production and demand for goods. John Maynard Keynes articulated an alternative model focuses instead on investment and saving. How does that work? So private saving is equivalent to your disposable income minus what you spend on consumption, so minus C. From here, we know that disposable income is Y minus T. On the other side, when we think about public savings, it's T minus G, or what they collect in terms of taxes minus what they spend in terms of government spending. So T minus G is public saving. In equilibrium, we know that, again, assuming a closed economy, we know that Y equals C plus I plus G. Subtract T from both sides and move C to the left side. This will give us Y minus T minus C equals 1I plus G minus T. The left side of this equation is simply S, is savings. So S would equal I plus G minus T. And from here, we could just rearrange this to reach this equation, I equal S plus T minus G. This is the IS relation, which stands for investment equal saving. So we know that I equal S plus T minus G, and S here is private savings, and T minus G is public savings. And this is known as the IS relation, which stands for investment equal saving. So equilibrium in the goods market, there are two equivalent ways of stating the condition for equilibrium: production equal demand or investment equal saving. Let's now look at the saving. We know from the consumption behavior that S equal Y minus T minus C. Y minus T here is disposable income. C is the consumption. So we could replace C by the consumption function, which is C naught minus C1 multiplied by Y minus T. rearranging terms here, we could reach this equation, which is the saving function. So saving function here is minus C naught plus 1 minus C1 multiplied by disposable income, y minus t. So here 1 minus C1 is called the propensity to save, and it's going to be somewhere from 0 to 1. 1 minus C1, or 1 minus the propensity to consume, is called the propensity to save. It is worth noting here that the marginal propensity to consume plus the marginal propensity to save should equal 1 or 100%. Now let's drive the equilibrium equation using the new condition, or what we just learned about the other way of stating the equilibrium condition in the goods market, which is I equal S. So we can see here the saving function, minus C naught plus 1 minus C1 times y minus t, that's disposable income. And we know that the condition is that I equal savings, here S is private savings, and T minus G is public saving. So we could just simply replace that saving function instead of S here, and that continues with our equilibrium condition. And to solve for output Y, this will give us exactly the same condition that we obtained using the equilibrium condition of production equal income. It's just another way of driving the equilibrium condition in the goods market. And it's exactly the same equation. So we still see the main two components. We see the autonomous spending between two squared brackets, and we see the multiplier value, or the multiplier here is 1 over 1 minus C1. That's all for this video, and I will see you next video.